Hello, 5th and 6th graders. We are going on to the next chapter in science, which is 11.4, Thunderstorms and Tornadoes. So you can open your textbook to page 134. We're going to go over some vocabulary first, and then we'll read through the chapter together and go over the lab pages. So vocabulary for this chapter. Squall line, a row of severe thunderstorms. Tornado, a rapidly rotating column of air that extends from a cumulonimbus cloud and touches the ground. A Fujita scale, a scale used to rate tornado intensity. Thunderstorms and tornadoes reestablish atmospheric balance, even though they sometimes leave behind great damage. Thunderstorms are small, intense weather systems that bring strong winds, heavy precipitation, thunder, and lightning. They form when warm, humid air rises rapidly. The rising air cools, dense cumulonimbus clouds known as thunderheads develop. The air pressure drops and a storm results. When several thunderstorms are aligned in a row, it is known as a squall line. Lightning occurs as a result of the movement of air within a cloud, which produces opposing electrical charges. When the space between the positive and negative charges reaches a certain point, the charges are released as lightning. Thunder is the sound that results from rapid expanding of superheated air through which the lightning travels. When severe thunderstorms form, often the resulting in cumulonimbus clouds will take the shape of an anvil. I don't know if you've ever seen movies with blacksmiths in it. They have this metal structure that has like a base, and then it kind of goes out flat on top, and that's what they use to pound swords on or whatever they're making, horseshoes. It's a flat surface that's hard enough that you can pound heated metal on in order for it to take shape. So that's what an anvil is. And so these clouds take an anvil-like shape. You can see the picture on the bottom of the page where it has kind of this curved bottom and then flattens out across the sky. All right. It may even produce hail. These types of powerful thunderstorms are called supercells. Meteorologists begin looking for tornadoes once supercells are spotted. Waterspouts are spinning columns of rising moist air over bodies of water. They can form in fair weather or be the result of a tornado that passes over land to water. A cumulonimbus cloud forms its anvil shape when it expands to the top of the troposphere. The flat top indicates that it may produce strong storms and tornadoes. Quick fact on the side. Waterspouts, tornadoes, and dust devils have the same motion, but form under different conditions. Most waterspouts form over coastal waters and exhibit winds of less than 108 kilometers per hour, about 67 miles per hour. They typically move slowly, if at all. However, some waterspouts can start as tornadoes over land and then move over a body of water. This type can be very destructive. Tornadoes threaten life and property and stem from a downward cloud formation associated with thunderstorms. Dust devils form from swirling winds under sunny conditions during fair weather and are usually harmless. You can actually see some of these sometimes. I actually saw one outside today, a really small one, where you have wind patterns, if it's really windy out, where all of a sudden you see leaves or dust and it's making a swirling motion in one spot. And it usually kind of goes up, might expand out a little bit, and then just dissipate. And so those are called those dirt devils, kind of like the vacuum cleaner. Dirt devil, but it's just a small cell of wind that's being thrown into a rotating manner, and those are not destructive, obviously, just to the leaves it's blowing around. All right, on to the next page. Occasionally, a tornado can develop along a squall line. A tornado is usually a rapid rotating funnel cloud that develops from a thunderhead. Although a tornado is typically brief, scientists speculate that its wind speeds can reach up to 512 kilometers per hour. That's 318 miles per hour. That's pretty powerful. Most, however, are weaker, with winds less than 177 kilometers per hour or 110 miles per hour. Still pretty fast. Hail is often produced in severe storms along with tornadoes. The updraft and downdraft in a cumulonimbus cloud cause water droplets to repeatedly move upward, freeze, and fall a short distance until they become large enough to fall to the ground. Many times, a dark green sky color accompanies tornado formation. So if you have family members or friends that live in the Midwest where there tends to be a lot of tornadoes, you can ask them, like, what does it look like when a tornado comes? And there is like a greenish tint in the sky. That's a sheer sign that a tornado is on its way. And the amazing thing about tornadoes too, when you have a hurricane, which we're going to read about next, that's pretty destructive over large areas of land. When it comes to a tornado, it's very specific in its spacing. And so you can have a majorly destructive tornado take out one whole side of a street, houses, cars, trees, and the other side of the street will be completely damage free because that energy and that power within the tornado is contained within that funnel, whereas a hurricane is spread out over large areas of land and affects everything around it. A tornado's intensity is rated on the Fujita scale, which ranges from an F0 to an F5. The intensity is based on wind speed and how much damage the tornado causes to structures and vegetation. Tornado safety plans are important to have in place. In the event of a tornado, people should stay away from windows, move to a basement or the middle of the ground floor, and never try to outrun a tornado. We talked about how fast that was going. You can't outrun a tornado. There are people, if you're a thrill seeker when you're older, whose job it is to follow tornadoes or to quote unquote chase tornadoes, to research them. They are researching the direction that it moves in, the size of it, the speed that it moves, how fast it forms. And so there are tornado hunters that are weather people, scientists, whose job it is to listen on the radio for tornado landings or start beginnings, and they drive to where it is and they take research from it. So pretty intense job, but for some that is exactly where they want to be. And it's good for us because it helps towns and cities know how to best plan for tornadoes, how to put in place emergency plans, escape route plans. Maybe it's an alarm system that goes off in a town when a tornado is approaching so that everyone has fair warning to be able to get to a safe spot. In the Midwest, I'll be places that have a lot of tornadoes. A lot of times people have like a storm cellar that they build outside the house, which is kind of like a bunker underground that they dig out, and it might have a hatch to get into it, but being underground can be the safest place to be during a tornado. And so you see that. You don't see that again as much around here because we don't get tornadoes. In hurricanes, you're safe in your house. But a tornado can take your house depending on the severity of it. And so a lot of times people will choose to go underground if they have that capability. Strange but true. Evidence of a wall cloud, large-sized hail, unusual sky color that is most oftentimes a dark green, and a loud roar similar to a freight train can indicate a tornado. And if you look on the bottom of the page, you have a map there that kind of maps out a couple areas that typically, on average, have the most tornadoes. So the majority of the world's tornadoes occur in the Midwest region of the United States, known as Tornado Alley. You can see that in the pink in the middle of the map. Cold, dry air masses from the north travel southward where they meet with warm, moist air masses coming from the Gulf of Mexico. As the two collide, instability in the atmosphere results in storms forming. And so you've got cold air from the north and warm air from the south coming up, and when they meet together, they start causing these thunderstorms or tornadoes where that air just gets into a rotating motion and it builds from there. So you have, it shows pictures, the green is the cold, moist air coming up from the Gulf of Mexico. You see that little red line with the curves on the top, that's the line for a front. If you hear, oh, there's a cold front coming in or a warm front, that's a mass of air or a body of air that's coming through that's of a differing temperature than what is currently overhead. And so you've got this warm air mass moving north. You have this cold air mass moving south, which indicated with the blue loop with the triangles pointing down. And so when you have the two of those and you have warm, dry air coming from the continental south, Mexico, and then you have the jet stream coming in as well. All of those factors together in the middle of the country come together and form major tornadoes. And so that's why you see a lot of them out there. And plus it's very flat out there in the Midwest, and so it's not as mountainous where this happens, and so tornadoes can do a lot more damage because they just move across a flat plain. All right, I encourage you to go on YouTube or go on National Geographic and look up some videos on tornadoes and thunderstorms. There's some really fascinating information about tornadoes and the science behind it. So see if you can find some great information to do a little bit of extra learning on tornadoes and thunderstorms. Going over to your lab book. So in your lab book, we're doing 11.4a and 11.4b. And so on 11.4a, you're doing tornado frequency. So how often tornadoes happen. And I know your book has a little bit different numbers than mine. So if you have questions on it, my answers are going to differ a little bit. And the answers that I sent your parents are going to be different. But just do your best on it. So basically what you're doing is you're analyzing that map. It says, observe the map below of the United States. The number inside each state represents the average number of tornadoes per year per 26,000 kilometers or 10,000 miles squared that occurs in a state between the years of 1953 and 2004. Determine the top 7 states that have experienced the greatest number of tornadoes. If needed, use an additional map to identify the names of each state. Write the state name, their abbreviation, and the average number of tornadoes in the table below. So looking at that map, if you don't know the name of some of the states, you can look up a map. You can use your social studies book to find the names of the states. So in the chart below, you're writing the name. You're going from greatest amount of tornadoes to least amount within the top 7 most tornadoes on average. So you're writing the name, the abbreviation for the state, so the 2 capital letters that represent that state name, and then the annual number of tornadoes, okay, indicated by the number on the map. On 11.4b, it's a graphing project. So graphing and analyzing. Construct a bar graph using the data from the chart on Science Notebook 11.4a tornado frequency. Label each axis with the appropriate terms and give the graph a title. Use the state abbreviations. Plot the average number of tornadoes for each of the 7 states and fill in the bars. So you're making a bar graph, which we've been doing in math, and your information, your labels along the bottom, your graph should have the state abbreviations. So you should have 7 different state abbreviations. And then up the side, you're going to be doing number increments. And so the average number of tornadoes. And you can go up in increments of 2 or 1 for each line, whatever works, but you don't need to go greater than 10. Because none of the tornadoes, or actually on yours, I think it does go up to 12. So don't go higher than the highest number that is indicated, and then graph it from there. If you have any questions, please let me know. Again, try and find some information, National Geographic for Kids, or Discovery Channel, and look for some videos of tornadoes and the science behind it. And look for, I think there's actually a show called Tornado Hunters, and so that's something that you can look at as well to see what that job would look like. Thank you. I will see you next time when we move on to hurricanes.